Hi everyone. Today we're going to study homogeneous differential equation. Let's begin with homogeneous function. A homogeneous function of degree n is a function in which all terms are of degree n. We have here three examples. Number 1, f of xy equals x squared plus y squared. In here, we can see that all terms are of degree 2. So we say that this function has degree 2. Example 2, f of xy equals the square root of the quantity x raised to 8 minus 3x squared y raised to 6. In this example, the terms inside the radical have degree 8. But because of the square root here, the degree will be 4 for this function. Third example, f of xy equals 2x plus y. In here, the degree is 1. We have now homogeneous differential equation. A first-order differential equation, that is the function m of xy dx plus the function n xy dy equals 0, is said to be homogeneous if the function m xy and the function n xy are both homogeneous functions of the same degree. Sometimes it is represented as dy over dx equals f of xy over g of xy. We have steps in solving homogeneous differential equation. This is step 1. Substitute y equals vx and dy over dx equals v plus x times dv over dx to the given equation and solve. In the step 1, we have here two equations. The first equation is y equals vx, and the second equation is actually the derivative of the first equation with respect to x. Then step 2, in the final answer, replace the value of v by y over x. Let's have example 1. Find the general solution of the differential equation dy over dx equals x plus 3y all over 2x. This is a homogeneous differential equation of degree 1. For our solution, the step 1 is we substitute the two equations in the given equation. The left side now becomes v plus x times dv over dx equals, the right side is the x plus 3y becomes x plus 3 times vx all over 2x. Look at the numerator. There is a common factor, and that is x. So we simplify the numerator by removing the common factor. So it becomes like this. By doing so, we can see that the x is common in the numerator and in the denominator. So we can cancel both the x. So the right side becomes like this. It is now simplified into 1 plus 3v all over 2. The next step here is this v variable we will transpose to the right. So it becomes negative. Then we combine this fraction by this negative v. So it will be combined into 1 plus 3v minus 2v all over 2. Then we combine this 3v minus 2v. The right side now is simplified into 1 plus v all over 2. From here, we will do variable separable method. We will do cross multiplication to put variables together. So it becomes like this. 2 dv all over 1 plus v equals dx over x. And from here, we will integrate both sides. The left side is now 2 times the natural log of the quantity 1 plus v equals, and for the right side, this is equal to the natural log of the absolute value of x plus the constant. Since we see here a pattern of natural log, we can write natural log for the constant a. We will now apply the rules of logarithm on both sides. The left side now is natural log of the square of the quantity 1 plus v equals, on the right side, we can combine this x with the a. So we have natural log of the product capital A times x. And from here, we will cancel the natural log. So our new equation is now the square of the quantity 1 plus v equals ax. We're almost done. We'll just go for the second step by replacing the value of v by y over x. So it becomes like this, 1 plus the quantity y over x. And this is squared equals ax. This is now the final answer. Example 2. Find the general solution of the differential equation. dy over dx equals y over x plus the tangent of y over x. Let us substitute the values to our equation. The left side now is v plus x times dv over dx equals, our y over x becomes vx over x plus the tangent y over x becomes tangent vx over x. We can simplify the right side by cancelling the x respectively. So it becomes like this, v plus tangent v. In our new equation here, please observe we have a variable v and a variable v from both sides. So this v here, if we transpose on the right, it becomes negative v. That can cancel the v on the right. So we can simplify this equation into like this, x times dv over dx equals tangent v. And from here, we will do separation of variables. We will do cross multiplication, and the new equation becomes like this, dv over tangent v equals dx over x. On the left side, we can apply trigonometric identity. So the left side now becomes cotangent v dv equals dx over x. So we apply integration for both sides. The left side is now the natural log of the absolute value of sine v equals integral of dx over x is the natural log of the absolute value of x plus, for the constant which is c, we can apply the natural log also. The right side can be simplified into natural log of the product c times x. Then we remove the natural log from both sides. So we have now sine v equals cx. We're almost done. And the second step is to replace the value of v by y over x. So we have now sine of the quantity y over x equals cx. This is now the final answer. Example 3. Find the general solution of the differential equation x times dy over dx equals x plus y. We substitute the corresponding values to our equation. So the left side is now x times the quantity v plus x times dv over dx equals, the right side here is x plus y. So we have now x plus vx. On the right side, x is common, so we can factor it out. So we have this x times the quantity 1 plus v. We can observe that x is common to both sides of the equation. So we can divide this equation by x so that the x will be removed. The new equation now is v plus x times dv over dx equals 1 plus v. For this new equation, the variable v is common. Again, we say that this v, if I transpose to the right side, it becomes negative v. That will cancel the positive v here. So we can simplify this equation into x times dv over dx equals 1. At this point, we can do separation of variables. We do cross multiplication and we have this new equation. dv equals dx over x, where we will apply integration to both sides. The left side is now v equals, the right side is the natural log of the absolute value of x, then plus c. Step 2 is replace the value of v by y over x. So the new equation is y over x equals natural log of the absolute value of x plus c. This is now the final answer. I hope you learned something from this video. See you again next time.